let's talk about radicals. Radicals are those fractional exponents like you see here, and sometimes they're illustrated by a square root symbol like that right there, that thing. Occasionally you'll see a cubic root or basically any x root. To start off, we're going to talk about how to simplify them, and we'll get down to what a radical really is. What is a radical? So let's start off with that. What is a radical? A radical is just some number raised to a fractional exponent. So if you have x to the 1/3, well, that would fall under the category of radicals, and they're harder to evaluate than regular exponents, because normally with an exponent you have like an integer power, like x to the 1 is just x, rather. So the most common radical you'll see is some number to the 1/2, and that's the same as the square root of some number. So let's start off with something that let's start off with an example. How do you evaluate this? So let's say that we have the square root of 4. So when we're doing the square root, let's think of this exponent. So since it's the square root, this is really just 4 to the 1/2, because that's how you define the radical. If it was the cubic root of 4, it would be 4 to the 1/3. So this is 4 to the 1/2. So how else could we write 4? Well, if you write it as 2 times 2, that's the same as 2 squared. If you have x to the a all to the b, that's the same as x to the a to the b. The exponents just multiply. So if you can write 4 as 2 squared, then we could write this, and I'm going to write up here, as 2 squared all to the 1/2. And then you just multiply those and you get 2 to the 1, which is 2. So the square root of 4 is 2. And this makes sense, because what we mean when we say square root is what number times itself will yield x. So 2 times 2 does in fact equal 4. So that's what we mean when we're talking about a radical. Now let's say if we were going to go one step further, like the cubic root of 8. So you can write that as 2 cubed all to the 3rd, and that's just 2. So it's the same thing. You're just doing the same thing. The problem comes when you have something like the square root of 8. No integer times itself will give you 8. How can we simplify the square root of 8? So let's go back to rewriting those numbers. Let's write 8. Instead of writing it as 8, let's write it as the square root of 4 times 2. So we're going to use a property of exponents. So let's say you have, before I go through, I'm going to prove this. Let's say you have x, y, all squared. That is the same as x squared, y squared. You can prove this really quickly. Xy, this is just xy times xy, and that is x, y, y. So we can rewrite this as the square root of 4 root 2. And we can do that because this property holds true for fractional exponents as well. So root a b equals root a root b. So once we write it like that, we can rewrite this as 2 root 2. But let's see how this plays out with some other things, and we can develop a general method for how to do this. So let's say you have the square root of 48. So our approach to this would be, let's rewrite it. Square root 48 is divisible by 4. It's divisible by 4 times 12. Okay, so let's rewrite that. That's equal to the square root of 4, and 12 is just 4 times 3. So now we have these two 4's here under the square root. So let's rewrite it again. Square root of 16 times 3. And then we can just break this up. The square root of 16 root 3, and that's just for root 3, because the square root of 16 is 4. So what about if it's not a square root? What if it's a cube root? What if we had the cube root of 16, cubic root of 16? That's terrible. Okay, so for clarification, I'm just going to write it as 16 all to the 1/3. So let's rewrite this as 8 times 2 all to the 1/3. Well, 8 is a perfect cube. We can write it as 2 cubed. So let's break this up into 2 cubed to the 1/3 all times 2 to the 1/3. And these cancel out, and you just get 2 times 2 to the 1/3. And we can't combine these because based on order of operations, you have to do exponentiation first, so this is the simplest we can get it. So as a general formula, whenever you have some number raised to a fractional power, first you're going to want to identify if x is a perfect whatever. So if n is 2, you want to know if x is a perfect square. So numbers like 1, 0, 4, 9, 16, think numbers like those where integers are the square root, and that applies for cubic roots too. So numbers like 8, 27, 1 again, 0, that would work for those particular numbers because they fit the criteria that an integer can be multiplied by itself a certain number of times to yield that number. However, if x is not a perfect square or a perfect cube, then what you want to do is look for numbers that are perfect whatevers that do go into x. So if you had 16 and you were doing a cubic root, like we were doing one example ago, you'd want to do 8. 8's a perfect cube. Or if you're doing the square root of if you're doing the square root of, let's say, 125. Well, 25 goes in there, and 25, the square root of 25 equals 5. So you could break that up pretty easily. So this is the general method that we're going to use to try to break up square roots. And remember, this all works. You can simplify it like this and like this because we know that a b to the n is a to the n times b to the n. So you can break up these different components of the problem.